All right. Okay. Good evening. Am I audible loud and clear? What about the audio? You hear me, right? Yes. Okay. All right. Once again. Okay. Once again. Okay. Right. Good evening again. Good evening. So, how was the week? You're doing good. Is it? Okay. And when you send messages to Zoom chat, don't send them as direct messages because then I won't see it automatically. It's going into a separate chat box, right? Then I won't see it. So therefore, put all of your messages to the main chat, right? Then instantly I can see. I mean, automatically I can see. All right. Okay. Then yeah, let's go to today's things. Now, as planned last week, now today we are starting the new lesson, fresh lesson, the fresh month, projectile motion, right? So last week it was a very effective class. Last week we first thing we finished linear motion, right? We finished linear motion, and then you had your first exam. You had your first exam, right? And I didn't finalize your final marks yet because from the ones who are watching the recordings, some submissions were coming in during the week. So therefore, I didn't finalize the marks yet. But after today, I'll be finalizing all of your marks for exam 1, right? For the exam 1 you had, right? And as I told you, month on month, Right, now you are going to have exams based on the past things you have covered as you had last day, right? So that is how it is going to be. That is how it is going to be. All right. So it was a very effective class because of the exam and the ending of the linear motion. Right, now today we are starting the new lesson, fresh lesson, projectile motion. Right, so we are starting projectile motion. Right, okay, right. And as I wanted to merge your class with my regular batch in the last week, as I asked you to do it, right now, most of you said that you had different plans, right? Thanks for reminding. Yeah, thanks for reminding. Right, but now let us by next month. Let us by next month we have to merge these two classes, as I was telling you from the first day onwards of the class. Now there is a high time to merge these two, right? So therefore, by the next month onwards, by November, your class will be merged with my regular class. The regular class is happening on Fridays from 3:30 to 6:30, right? So during this month, we will cover all the things we have to cover, and in November, you will be attending both classes, right? During the month of November, you will be attending both classes. Once you purchase the new batch class, right? You can freely join the regular class, right? And after November, you will be fully merged to the regular batch, right? So that is how it's going to be as we planned in July. As we planned in July, right? Yeah, that's a plan. July in the sense we started the class in the last week of July, so almost August, right? So that is how we planned at the beginning. So therefore, that is what I also need to do now, because now since we are also chasing up the regular batch, right? So we know initially we had a difference of how many months? 4 months when you start the class. When we start the class, we had a difference of 4 months, right? But now the difference is actually taken down to like around 2 months with the faster catching up process we have done, faster catching up program we have done, right? So yeah, that's the announcement I have. By the next month onwards, right, we'll be starting to merge, which means during the month of November, you will be attending both classes, right? From this end, I'll be covering the parts in the new batch class here, and from the ongoing class, you'll be covering the points onwards, center of gravity onwards, right? Okay, that is how it's going to be. Okay, then let's start. Okay, take down the heading as projectile motion. Projectile motion. Projectile motion. Projectile motion. Projectile motion. Right. So tell me your thoughts about projectile motion, which means what does comes to your mind when I say projectile motion? Do you have any thoughts? Have you heard about projectile motions before? Or are you hearing about projectile motions for the first time? Tell me, what's the thought you have? So then do we need to join the class on Friday? We get regular class time. No, regular class time is fixed. That is Fridays from 3:30 to 6:30. During the first month, you will be joining both. And then after the uh, indication is completed, right, you only need to join the regular batch, because now I have 2 batches for 27, right? But having 2 batches is not something that we can continue further, because you are going to have your first term exams, second term exams, and all other term tests coming up in the same timeline, right? So therefore, we need to merge. So when we merge the classes, shift to Friday, it is like this. See, don't misunderstand. Now, I will start merging. Start merging means you will be merged on the first week of November. See, November merge karna. In November. So in November, you have this class, this new batch as usual. You have this new batch as usual. And plus you can join the regular batch. You can join the regular batch from center of gravity, from that lesson onwards. You can join the regular batch at the same time. You can, in the sense, you have to, right? Then during the month of November, you have to join both, right? For joining both, you only need to purchase the new batch class. You only need to purchase the new batch class. Once the new batch is purchased, I'll make it free to join the regular batch, right? I'll make it free to join the regular batch. Is it clear? Only purchase this thing. Only purchase this thing. Right? And then December onwards, December onwards, right? That will be only the regular batch. Then both of the batches are combined as one batch and will be moving together. You will be moving together. Then only the regular batch, right? Regular batch. That is on Fridays, 3:30, 6:30. Right? December onwards. Then there won't be a new batch. There won't be a new batch class, something called a new batch class after December, because all of you have come into the, you will be coming to the same point, right? Same position. Then we are moving together as the same batch, of 27 A levels, right? Is that clear? So during the month of November, you don't need to purchase both classes. Only purchase the new batch class, only the new batch class, right? Only the new batch. Then during that month, during that particular month, I'll make you free for the regular batch, right? I'll inform you the process, right? Process එක කියන්නම් එතකොට ඒ විදිහට enroll වෙන්න පුළුවන්. Is that clear now? And after December, that will be only on Fridays. The regular batch එකනේ, normal regular batch එක විදිහට තමයි යන්නේ as a single batch. Any more questions? Is it clear? Now you might have forgotten. I mentioned that in the first week itself in the class. That was on Fridays anyway. Any questions? Any more questions? Is it all clear now? It's clear. Tashvi, what about you? Tarsana, clear. Okay. Tashvi, what about you? Is it fine? Clear, right? Okay. It's fine with you, right? Right. So keep this in mind. I'll remind again by the next month. Okay. Now let's go to the lesson. No, sir, I can't do Friday 3:30. Then now, if you are joining the class on Fridays, then what you can do is you can cover up the hours you are missing with the recording. That is the main option you have got, right? So you can still join to the class, and if the class is on Friday, the recording will be available by Saturday. So in that way, that is one thing that you can do to cover up, right? Say you are missing 1 hour, 1.5 hours of the class. When you are coming back, then for that 1 hour, 1.5 hours thing, you can go through the recording and cover it up, right? It's a doable thing, right? Okay, projectile motion. So tell me, any thoughts you have about a projectile motion? Any thoughts? What a projectile motion is? What a projectile motion is? Any thoughts? Don't need any definitions. Just tell me, what do you think? What's the idea you have about a projectile motion? No idea? Right. So it is like this. Anyone has heard about the word parabola? Parabola. Anyone has heard about the word parabola? Parabola. Have you heard the word parabola? Sorry. Who has heard the word parabola? Yes. Right. So parabola means that's a specific type of a curve. Parabola means that is a specific type of a curve. When you draw a, a minima or maxima graph, a maxima or minima graph, right? The shape you are getting is called a parabola, right? That particular shape you are getting is called a parabola. If a motion undergoes, and this path is called, this shape is called the parabolic shape. Parabolic shape. Sorry. This shape is called the parabolic shape. This is called the parabolic shape, right? So if any motion undergoes, listen. So yeah, getting the start, we are taking the start. Listen, if any motion undergoes in a parabolic path, if any motion undergoes in a parabolic path, when the path that motion is called a projectile motion, right? So we'll see how objects are undergoing in parabolic paths. So, right, as an idea, projectile motion is a motion which undergoes in a parabolic path. Now, since you already know about linear motions, you can compare this with what you know in linear motion. What linear motion was? A straight motion. A motion undergoes in a straight line. A straight line. That was a keyword, no? Linear motion was a motion undergoes in a straight line, right? And projectile motion is a motion which undergoes in a parabola, in a parabolic path, right? So compare and contrast these two. In linear motion, we had a motion in a straight line. In projectile motion, you have motion in a parabolic path. That's a curve. That's a curve. That is not a circle, but a parabola. But a parabola. Right? Okay. Mention this first point below the topic. Mention this point, write down. The motion undergoes, write down. The motion undergoes, the motion undergoes in a parabolic, in a parabolic, in a parabolic trajectory, like this. The motion undergoes in a parabolic trajectory. The motion undergoes in a parabolic trajectory, slash path. The motion undergoes in a parabolic trajectory slash path. with a constant acceleration, with a constant acceleration, with a constant acceleration along a particular direction, with a constant acceleration along a particular direction, with a constant acceleration along a particular direction is called a projectile motion, right? Is called a projectile motion. Right? And another small thing, listen, another small thing. Now, once you do the payment for the class, now don't send it to me, right? Now, I noticed that some of the students are sending the payment slips to me. Still, they are sending the slip to me. And some of the students were sending it to the group, batch group, right? So, no need to do anything like that, right? If the payment is done, go to the website, log into the class, right? Go into the class, and under the class, you will see the months. Then, now this is the month of October. No? So, go to month of October. Under month of October, you will see a button called monthly payment. You will see a button called monthly payment. Click on that button. Once you click on the button, you will see a cage with the plus mark. Then, by pressing that plus mark, upload your file there. Upload your file. File in the sense the payslip. Upload your payslip there, and below you will see a button as save. Save it, and then you will see a green color message as submitted for grading. Right, submitted for grading, which means your payment has been sent for the approval. Once your payment is done properly, you will get an automatic email as a confirmation. That is the evidence that you have uploaded it successfully, right? Then it is sent to the approval. Once it is approved, then again you will get an email saying your payment is approved. Now, when that payment is approved, then you can access the remaining weeks of the month. That is how it is going to be. So therefore, don't send payslips to me or to the group, right? Directly upload it to the website, right? Directly upload it to the website. Right, then from my side, I'm getting the approval, then I can check your payment and give you the approval. Right, now everything is done through the website only, right? So otherwise I can't track actually. So using the website, we can track it, right? So that is how it should be. Okay, look at the board. Now I notice that most of you are familiar with the process by now, right? So for the last month also, there were some of you requested recordings by doing everything proper on the website, right? So they got recordings from the website, and I saw some September payment slips were also uploaded to the website, right? And you had the exam, so you got that experience as well, right? How we are conducting the exam from the website, right? So likewise, now by now it seems most of you are familiar, but yet there are few of you still not that familiar with the website thing. So this is how it should be. Upload it there, and then otherwise if that is not uploaded, you will see a message as you can't access that week until the approval is done or something like that, right? Okay, now look at the board. Now this is an axis panel, X and Y, right? And from here to here, I'm going to consider a projectile motion. See, now this is an example projectile motion, right? So let's assume we have an object here. Look at the board. We have an object here, and this object starts a motion at t equals 0. And this object starts a motion at t equals 0. And after some time, the object has moved to this point, and after some time, the object has moved to this point, and again here, 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 here. So likewise, now the object is, this is the path. This is the path traced by the object when the object undergoes in the projectile motion, because projectile motion is a motion like this. If the object undergoes in a parabolic path like this, that is called a projectile motion. Now, if I throw this pen with an inclined velocity like this, see, this is going to be a projectile motion. If I throw the pen with an inclined velocity, see, this is going to be projectile motion, right? If I throw upwards, that is a vertical motion. But if I throw it with a inclined velocity, see, that is a projectile motion. So likewise, now what I have marked here is, random points, few random points on the path of the projection that we can see, right? Starting from here. And finally, when the object reached here, let's say that is C equals C, the completion of the motion, right? Now, I'm going to identify the position of the object. Listen very carefully. This is the most important part you need to understand here in projectile motion, right? Once you understood this concept, right, doing projectile motion questions is nothing, right? Because the concept is here, right? The opposite is, if you didn't get the concept, right? If you didn't get the concept, then the opposite is also there, that matters. What happens is, if you didn't get the concept, you will be stuck when you do calculations, when you do sums, right? So therefore, be focused and look at the board. Now I'm going to understand and identify the positions of the object with respect to x-axis and y-axis of this axis panel. See, now when the object is here, with respect to x-axis, it should be somewhere here. No? It is here. So when the object is here, actual object is here, right? With respect to x-axis, the object is somewhere there, right? And in physics, listen, and in physics, this is called the projection. In physics, this is called projection. What is projection? So in basic words, projection means shadow. In basic words, projection means shadow, which means now when this object travels in this path, along the path, right? If I got the shadow on this x-axis, right? This is the point where you are going to see the shadow. Is that clear? Now, if you can't imagine, what you can imagine is, let's say the object travels in projectile motion like this, and you need to see the shadow at the bottom, right? So simply what you have to do is, you can place a torch somewhere here like this. You can place a torch. Once the torch is placed, you will see the shadow at the bottom, right? If you need to take this shadow onto this kind of a surface, right? Place your torch like this. Then you will get the shadow here, right? So likewise, what actually we are taking here is projection of the actual object. Projection means shadow. This is called the horizontal shadow, horizontal projection, and this is called the vertical shadow, vertical projection, right? So that is how I'm marking this point. Shadow එක තමයි මේ mark කරන්නේ. වෙන මොකුත් හිතන්න එපා, මේ shadow එක mark කරන්නේ. Horizontal axis එකේ තියෙන shadow එක. When this is here, the shadow is here. When this is here, the shadow is here. When this is here, the shadow is here. So likewise, these are the positions of this shadow when this object moves. These are the positions of this shadow when this object moves. Right? These are the positions. These are the positions. Are you clear about that? What I did there? Right? Now, you don't know anything about projectile motion yet. Just tell me whether you understood marking the shadow like this. Have you understood marking the shadow? Yes. Right? So similarly, I'm going to get the shadow on vertical axis as well. See, I'm going to get the shadow on vertical axis as well. When the object is here, the shadow is here. When the object is here, shadow is here. So likewise, see, we can get the shadow on the vertical axis as well. Now, when this is coming back, the shadow is again coming back to this point. When this is coming back, the shadow is again back at this point. When this comes back, shadow is back at here. When this comes back, the shadow is back at here. Right? Now, we are going to observe and study, listen very carefully, we are going to observe and study the behavior of motion of the shadow. You are going to study, you are going to observe the behavior of the motion of the shadow, not the actual object, the shadow. That is called the projection in physics. Right? See, this projection starts here. Look at the board, look at the board. This projection, horizontal projection, starts here. And time to time, time by time, right? The projection moves from here to here like this. Got it? And the vertical shadow starts here. Vertical shadow starts here and moving upwards like this up to the maximum point. And at the maximum point, it turns and can you see it comes down? It comes down again up to this point. Right? Tell me whether it's clear. I just observed and noticed the behavior of the shadow. Behavior of the shadow. This shadow moves from here to here. When the object travels from t equals 0 to t equals t, horizontal shadow travels from here to here. Vertical shadow travels to the maximum point and comes back. Let's say these points are A and B. Have you got this concept? Have you got this idea? Not a concept. Have you got this idea? Have you got this idea? Students? What do you say? Yeah. Okay. Now, keep looking at the board. Keep looking at the board. Which means, look at the board, which means when the actual object travels from here to here, when the actual object travels from here to here, like this, right? When the actual object travels from here to here, the horizontal shadow travels from horizontal shadow travels from A to B in a linear path like this. Can you see? When the actual object travels in projectile motion, right? This travels in a linear motion, linear path from A to B, right? And about the vertical shadow, vertical projection, when this travels from here to here, this goes back and forth. This goes back and forth like this in a vertical linear motion. Right? Therefore, the first idea is actually the projectile motion is a combination of two linear motions. Actually, projectile motion is a combination of two linear motions. One is a horizontal projectile motion, and the other one is, one is a horizontal linear motion, and the other one is vertical linear motion occurring at the same time, simultaneously, concurrently. Got it? මේ දෙකම එකපාර වෙලා තමයි projectile motion කියන එක as a result හැදිලා තියෙන්නේ. Right? Which means the combination of this horizontal linear motion and this vertical linear motion gives a projectile motion as a resultant. As the resultant. Right? Is that idea clear? Tell me. Is that idea clear? Yes, very good. Superb. Clear. Superb. Right? That is why this motion is called the projectile motion. The idea is, right, this is a motion we study using two projections, no? This is a motion we study using two projections. So therefore, it's called a projectile motion. Right? Now you know what a projector is. Right? May word example. You know what a projector is. Projectors you don't know. So by using projectors, what is done? A shadow is projected onto a screen. That's a projector. A shadow. That is why you need a white screen to project something using a projector. Right? Projection means shadow. That is why that instrument is called the projector. Got it? That is also a shadow. That is the idea. Okay. Now, very clearly take this diagram down very clearly. If you are using different colors, you better use different colors. Yeah, Kashi, about that Friday thing, you can drop me a private message. We'll see what we can do. Right? I'll consider it. I'll consider it. Otherwise, I'll forget. After the class, send me a private message. We'll see what we can do. Right? Are you going to have schools up to at which time you are going to? I mean, until which time you are going to have this school on Fridays? Up until 3:30. Is that the regular time, or you are having an extra class or extra session after school? Regular. Now, since the time of other schools is 1:30, now that is why usually I conduct the theory classes in Colombo at 3:30, because then the majority of students have more than enough time, 2 hours, no, have more than enough time to have their lunch and come to the class, right? That is why now, since regular time of the schools is 1:30, I usually conduct all my theory classes in daytimes by at 3:30. At 3:30, right? For 26 batch also, that is the same time, right? That's the after school time we have usually in the classes around Colombo, right? So that was the same time I have been conducting the classes for 26 batch as well. Right? So therefore, changing the Friday time is not that viable, because there is something coming from April. No, there is something coming from April. April, let's start regular batch class again, and there is a time I have allocated. I have been allocated from that institute as well. So when the class is on Fridays, if you need, you can join physically as well, because the regular class is going as a hybrid class, right? So where we have both. If you live nearby, you can physically come to Mashma College, Bumblebee, right? You can physically come to Mashma College, Bumblebee, and sit for the class physically. That is another advantage you can have when the classes are merged. Physical class is also there. And Tashi, do you have any possibility of coming to the physical class after school? No. I mean, before going home, if you are around Colombo, right? I think you live around Colombo, right? Have look somewhere. Then Bumblebee means that is like very next to you. There is another option, no? There is another option, because there the physical class is also there, right? So you can consider that as well. That I forgot to tell you before. You can consider that as well, right? Because my regular batch goes as a hybrid batch, right? So therefore, physically you can come there. Right. Take this down. Use different colors. What about the ones on YouTube? You also, if you also have questions, put that to the live chat. If you have anything to know, just feel free to put it to the live chat. And have you all got your tutes by now? The monthly tutes. Have you all got your monthly tutes by now? Yes. Who are the ones who didn't get? Now, by now, all of you should get your tute with a small gift. Did you notice that there was a gift inside the parcel? Right? Sorry. I'm not that well today. I have got a little cough. I don't know the reason. Somehow I have got it from somewhere, and now my throat is kind of like aching. Okay, finish taking this down. It was so lovely. Thank you. So you can wear it when you are going somewhere, maybe to other classes or somewhere else when you are going shopping. So you can wear it as a nice bangle like this, right? So when you are attending the classes, so if you are going somewhere else, right? So you can wear it, right? So that's the purpose of giving it to you, know. So you can wear it, right? So that was the one I printed this year, right? So next year we'll see if we can print another one, right? For this year, this was the one we printed, right? So I'm wearing it everywhere. You also can wear it if you are usually wearing bangles, right? Bands. So as the newest addition to your collection, you can wear this, right? Then everybody will get to know that you are attending to my class, right? You are attending to my class, right? Then everybody knows that you are a student of mine. That's the ultimate thing there, right? Okay. Then below this, write down first asterisk mark. Use a red pen. Use a red pen. First asterisk mark. Write down. Write down. First asterisk mark below this. When particle moves from A to B, when particle moves from A to B, when particle moves from A to B in projectile motion, when particle moves from A to B in projectile motion, it's horizontal projection. It's horizontal projection. So I told you what a projection is. If you don't know, you can write shadow within brackets, right? You can write the word shadow within brackets if needed, right? its horizontal projection along x-axis, its horizontal projection along x-axis, its horizontal projection along x-axis travels from A to B, travels from A to B, travels from A to B in a horizontal linear path, travels from A to B in a horizontal linear path, travels from A to B in a horizontal linear path, right? Then next asterisk mark, keep using the red pen. When particle moves from A to B, when particle moves from A to B in projectile motion, when particle moves from A to B in projectile motion, its vertical projection, this one, its vertical projection along y-axis, its vertical projection along y-axis travels from vertical projection along y-axis travels from can you label this point as point C? Students, label this point as point C. Label this point as point C. This one. Right? Travels from A to C. Travels from A to C. Travels from A to C. And comes back. Travels from A to C and comes back. Travels from A to C and comes back from C to A and comes back from C to A, in vertical linear path, Okay, then next point, again write as a main point with an asterisk mark. A main point again with an asterisk mark. Write down. Therefore, projectile motion is a combination of. Therefore, projectile motion is a combination of two linear motions. Is a combination of two linear motions. Which undergo in two perpendicular directions. Within brackets, horizontal and vertical. Within brackets, horizontal and vertical. Okay. So therefore, the idea you have to have up to this point is projectile motion basically consists of two motions, actually two linear motions. Projectile motion consists of two linear motions. One motion occurs linearly in a horizontal direction and the other one occurs in a vertical direction as a back and forth motion. The combination happens concurrently, and as a result, the projectile motion occurs. Right? Is that clear? So, any questions up to here? Now we have understood the background of a projectile motion, right? Background in the sense, now you have just seen what actually projectile motion is and what is inside the projectile motion. That is what we exposed here. That is what we opened up here, right? Any questions up to this point? Anything to clarify? Clear? Clear. Is it clear for all of you? Good. What about the ones on YouTube? What about the ones on YouTube? Are you all with me? Are you all with me? Any questions? Anything to know? Put your response to the live chat. Right. Then look at the board. We are going to move on. Look at the board. Okay. Take this down as a note. Take this down as a note. Take this down as a note. Right? Okay. So as a note, write down resultant vector of two perpendicular vectors. Write down resultant vector of two perpendicular vectors. Resultant vector of two perpendicular vectors. Say we have two perpendicular vectors as x and y. Right? The resultant means right? The resultant means the single vector. Listen very carefully. Single vector. Now this is actually a part we are going to go into much depth under vectors. A lesson coming up. But here, few parts from the vectors are also needed for the projectile motion. Right. So that is what I gave you under this note. Right. The part, small part, which comes in projectile motion from vectors. Right. Resultant means the single vector to replace these two vectors is called the resultant vector. Single vector to replace these two vectors, or in other words, the single vector that does the same task, the same thing that was done by these two vectors is called the resultant. Right? That is called the resultant. Resultant vector can be determined like this. This is a proved equation in vectors, right? In vectors, you will be proving this equation. Now, since we need that result for the parts today, I'm just giving you that proved result, right? So don't worry, we are proving this result in projectile in vectors, right? Resultant is called R, right? And let's say this direction is alpha. Direction is alpha. Now, what is proved is R can be written as root x squared plus y squared. R can be written as root x squared plus y squared. That is called the resultant vector. And if I need to find this angle, always the angle can be written as tan. If I need the angle, it can be written as tan alpha. As now, if we create the triangle here, if you create a triangle here, now if this side is y, this side of the triangle is also going to be y now. So therefore, we know tan alpha is opposite side over adjacent side y over x. If I need alpha, alpha can be written as tan inverse y over x. Tan inverse y over x. Right? So this is the magnitude of resultant. This is the magnitude of resultant. And this is the angle of resultant. Right? Right? So this is an idea which comes in vectors. Resultant vector. Resultant means the single vector to replace, right, two or more than two vectors. Right? Now as an example, who are the ones who watch cricket? Who are the ones who watch cricket? Cricket. Who are the ones who watch cricket? Cricket matches? No? No interest? Right? So good. Let's say Patum Nissanka. Right? Patum Nissanka is a batsman. Patum Nissanka is a batsman. Right? And take someone like Matisha Vatirana from the other side. Matisha Vatirana is a bowler. Right? Patum Nissanka is a batsman. Matisha Vatirana is a bowler. Now, if I take an example like Dasum Chanaga, right, who can do both batting and bowling, right? So such product is called the resultant. Such product is called the resultant, right? Patum Nissanka can only bat and Madisha Patirana can only bowl, but Dasun Chanaka alone can do both bowling and batting. So Dasun Chanaka is the resultant for Patum and Madisha, right? That's the idea. Let's say you have one friend that who can sing and you have another friend that who can dance. If there's someone who can do both at once, right, dancing while singing or singing while dancing, that is a resultant for both of them. Are you clear about the idea? That is the resultant vector. That is the resultant vector. Is that clear with that example? Okay, good. Right, good. Right, take this down. Take this down. And both of them will be proved under vectors. So therefore, here we are not going to prove this. Since we need these two for calculations, I'll be just explaining these two for the sake of projectile motion things. Take it down. Finished? Finished? The other thing is, the opposite of this. Opposite of this means if we have a single inclined vector, we can split it to two perpendicular vectors as well. Make them opposite එකකුත් තියෙනවා. Okay, first finish this. First finish this part. Finish this part as the first thing. Okay, now look at the board. The opposite of this is called dissolve components. Opposite is called dissolve components. Dissolving means splitting a single vector given into two perpendicular directions. First write down. After this, write down splitting a given inclined vector. Splitting a given inclined vector. Splitting a given inclined vector. Splitting a given inclined vector in two perpendicular directions. Splitting a given inclined vector in two perpendicular directions is called dissolved components. Is called dissolved components. Right? Dissolved components. Look at the board. This is how dissolved components are done. Look at the board. Now let's say I have an inclined vector like this. Say vector P is inclined by an angle theta. Vector P is inclined by an angle theta. Right? In such a case, look at the board. We can split in two directions like this. One more thing is dissolving is only possible with acute angles. This is only with acute angles. This is only possible with acute angles. Only with acute angles. This is only with acute angles. Right? Okay. Listen. Always, what we can do is we can take one component. This is also proved. This will also be proved under vectors. Right? We can consider one split of component towards the angle like this, towards the angle, and that component is called the cos component, cos, which means this is written as p cos theta. P cos theta towards the angle. Angle and the other component is away from the angle. Away from the angle is called p sin theta. P sin theta. Right? So in that way, we can represent this single inclined vector using two perpendicular vectors. Splitting. Dissolving means splitting, breaking. Right? Both of them are same. This is the dissolved components of P. That's a pattern. Towards the angle, cos component comes. Away from the angle, sin component comes. And always these two are perpendicular to each other. Right. Understood? Did you understand? Now I'm giving you a result. I'm showing you a result that we are proving in vectors. Huh? Yes. Okay. Take it down. And ask if you got any questions. Finished? So mention this in red, only with acute angles. This can be possible. This is possible only with acute angles. So why can't we label the axis X and Y? That is not an axis. These are the two splits of this P. Two splits, two perpendicular splits. Axis nemei, two perpendicular splits. Splits. Right? Now, as an example, see, as an example, I'll give you a few examples. Say you have 5 newtons here, like this. 5 newtons here, like this. 5 newtons. 5 newtons here. And if you need to dissolve this, one component comes here as 5 cos alpha, and the other component comes to the away from the angle side dash 5 sin alpha. That is the idea. That is the idea. This can be represented by using these two. This can be represented by using these two. One is towards the angle, the other one is away from the angle. Understood? Clear, good. All right. Then, as the next part below this, write down trigonometric ratios. Write down trigonometric ratios. Trigonometric ratios. We are still under the note. We are still under the note. We are still under the note. Trigonometric ratios. Trigonometric ratios. Right? Trigonometric ratios means these are the values of sine, cos, and tan for the popular angles. For the popular angles. Like this. Sine, cos, and tan. Right? This is the ratio. And this side is the angle. Right? We'll be starting with 0. Then 30, 45, 60, and 90. Right? So did I give you this table before? No, right? Did I give you this table before? Students? Under linear motion? No, right. So sine 0, this is like this. Now you will need these values. Listen, you will need these values when we deal with this whole component. That's why I'm writing. Right? You will need these values when you deal with these whole components, because you are getting sine and cos values, no? That's why. Sine 0 is 0. Sine 30 is half. Sine 45, 1 over root 2. Sine 60, root 3 over 2. Right? Sine 90, 1. Cos 0, 1. Cos 30, root 3 over 2. Cos 45, 1 over root 3. Values of sine 45 and cos 45 are same. And cos 60, half. Cos 90, 0. Tan 0, 0. Tan 30, 1 over root 3. Tan 45, 1. Tan 60, root 3. Tan 90, infinity. Right? So when we deal with cases like this, look at the board again. Look at the board again. Let's say, look at the board. Let's say you are going to dissolve a velocity like this. Say this is a velocity 100 ms minus 1. because dissolved components is valid for any type of a vector, any vector, right? Say this angle is 30. Say this angle is 30. Now, what you are getting in this direction is 100 cos 30 towards the angle 100 cos 30. Now, from here, you know, cos 30 is root 3 over 2, which means this is 100 root 3 over 2, which means this is 50 root 3. This is 50 root 3 ms minus 1. And to the other side, this is 100 sine 30. 100 sine 30 is half. This is 50 newtons. The idea is, sorry, 50 ms minus 1. 50 ms minus 1. The idea is the single 100 ms minus 1 vector can be split to two perpendicular vectors as 50 root 3 and 50. Right? The opposite of finding a resultant. As we are finding the resultant for two perpendicular vectors, when you have an inclined vector, it can be dissolved into uh, components as well, perpendicular vectors as well, right? So in such cases, we need these values. So that's why I'm giving you these values. These values won't be given in the exam. So therefore, now when we do questions, we have to now with the questions, with that comfortability and familiarity, you have to keep these answers in mind. Keep these values in mind, not the answers, values in mind. Got it? Take it down. So is the vertical one always no 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 oh, wait. I told you clearly. Towards the angle is cos. Towards angle, that is always cos. Towards angle cos. Right? If one side is towards angle, the other side is away from angle. No? Away from angle is always sine. Right? Towards angle cos. Away from angle is sine. Right? Towards angle cos. That is a pattern. So sine cos changes with the direction of with the side of angle you consider. Right? Take it down. So please repeat last topic. Last topic means you mean this trigonometric ratios. So before that, dissolved components. Is that you meant the last topic? Okay, finished? Yes. Yeah, Sally, what happened? You joined late, right? I didn't notice you at the beginning. What happened? After school? I was in YouTube. Okay. Right. So which means you joined at 7 when you start. Yeah, okay. Right. Now, from here, this note is finished. From here, this note is finished. Now, let's get back to our lesson again. Now, let's get back to the lesson again. Now, let's get back to the lesson again. Back to the lesson. See, back to the lesson. See, now the note is finished. So, if needed, you can draw a horizontal line and separate that part. Note is finished. Right. Now, as an example, write down. As an example, write down. Let's consider. Write down. Let's consider. Let's consider a particle projected. Let's consider a particle projected. Let's consider a particle projected with an initial velocity. With an initial velocity. With an initial velocity 100 ms minus 1, like this. With an initial velocity 100 ms minus 1. With an initial velocity 100 ms minus 1. And angle to horizontal. And angle to horizontal. And angle to horizontal 30 degrees. An angle to horizontal 30 degrees. Angle to horizontal 30 degrees. Right. Look at the board. Now it refers to something like this. Now as you all have been doing in linear motion, here also, now before solving the question, it is up to us to draw the sketch, draw a small diagram, a sketch diagram, right? So the sketch is like this. Look at the board. This object is projected. This object is projected with an initial velocity 100 ms minus 1. Initial velocity is at this point, right? With this angle 30 degrees, right? So this is the sketch I have. So let's say this is t equals 0 of the motion and this is the t equals t of the motion. And we'll label this point as point A, right? And this point as point B, right? So simply this is the sketch I have and this is the path of the projection. This is the path of the projection. Right, take it down. Take it down. Right. And now, listen. Now we are going to find out some parameters, some variables here in this projectile motion one by one, right? So you will find everything with me. You will find everything with me. So we'll be finding together, right? So after this, as ROM number 1, write down. As ROM number 1, write down. ROM number 1, write down. What's the maximum height? What's the maximum height reached by the particle? Write down. What's the maximum height reached by the particle? 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 Okay, listen now. Listen. Now tell me, when it comes to a projectile motion, right? It consists of how many linear motions? How many linear motions a projectile motion consists of? Two, right? One being horizontal and the other one being vertical. One being horizontal, the other one being vertical. Since it is a combination of two linear motions, we don't have any new equations for projectile motion, right? Since the projectile motion consists of two linear motions, we don't have any new equations to solve projectile motion, because if there is a combination of two linear motions, we already know linear motion equations. Then considering linear motions, we can use linear motion equations and solve projectile motion, no? So therefore, you don't have any new equations here in projectile motion. All projectile motion questions will be done using linear motion equation only, right? Repeating again, all projectile motion questions will be done only by using linear motion questions, linear motion equations. Got it? So therefore, once we are finding something, when we are finding something, always we have to focus on the two linear motions here instead of the actual motion, right? Now, since this is the first one, I'll explain from scratch. Listen, let's say this maximum point is, point C. Let's say this maximum point is point C of the motion. Tell me, students, from which point to which point the maximum height occurs? Now, according to my labeling, from which point to which point the maximum height occurs? Maximum height is a vertical height. Maximum height is a vertical height. Yeah, that is at C, which means the maximum height should be from A to C, no? From A to C. Is it clear? From A to C. Maximum height. Height means vertical height. A to C. Which means if I mark this as H, this is what it refers to. If I mark this as H, this is what it refers to. Maximum height. Right. Now, looking at this maximum height, tell me, does it relevant for vertical linear motion or horizontal linear motion? Now, දැන් අපි maximum height එක හොයන්න යන්නේ. maximum height එක කියන එක මෙන්න තියෙනවා. මේ maximum height එක කියන එක අපිට අර motions දෙකෙන් හිතුවොත් ඒක relative වෙන්නේ vertical එකටද horizontal එකටද? Now, if we think of the two linear motions we had before, right? To which linear motion maximum height is going to be relevant? Yes, exactly. That is a vertical linear motion. Therefore, if I need to consider maximum height, right, we are going to use an equation vertically upwards. Look at here. Mentioning the section is mandatory, as you did in linear motions. Mentioning the section is compulsory, it's mandatory, right? See, from A to C, vertically upwards. I'm going to use, since time is unknown, I'm going to use the equation v squared equals u squared plus 2a's. Okay, my next question, listen, tell me, what is the acceleration component acts on the object which undergoes in projectile motion? What is the acceleration component acts on the object which undergoes projectile motion? Tell me. What is the acceleration? Acceleration acts on the object. Acceleration component in the sense acceleration, yeah. What is it? Yeah, G, gravitational acceleration. That is only G. Direction of G is that we already know. Direction of G is vertically downwards. So therefore, throughout this motion, G acts vertically downwards. Right. Look at my application. Now I'm applying from A to C. Focus to the board. Right. I'm applying from A to C. My initial point is A. My final point is C. Then velocity at the final point. Tell me. Now, if that is about the maximum point, what can you say about the vertical velocity at the maximum point? Usual linear motion knowledge. What can you say about the vertical velocity? 0. Very good. 0. Which means vertical velocity at this point is 0. Vertical velocity at this point is 0. Because there is a maximum ever point that is reached by the particle. Right? We had the same idea in linear motion. Right? So therefore, this is going to be 0. And you, now, there's a problem. There's a problem. Listen, there's a problem. Now, my considered direction is vertically upwards. But this velocity is inclined. But that velocity is inclined. They are vectors. Since they are vectors, now I have to consider the vectors along my considered direction or opposite to my considered direction. Right? So therefore, we can't have an inclined vector to deal with. That is why we have something called dissolved components. So this is where the knowledge on dissolved components comes into play. Now I can dissolve this 100 as this. See, look at the board. I can dissolve this 100 as this. I can dissolve this 100 as this. Towards the angle, cos component comes. So this is 100 cos 30. Away from the angle, sine component comes. This is 100 sine 30. Is it clear? Now I think I answered the question raised by someone before. Who was that? Rashvi. Right? Cos is vertical, sine is horizontal, nothing like that. Right? Always towards the angle it is cos, away from the angle it is sine component. Then components of hundreds are 100 cos 30 and 100 sine 30. Is it clear? Yes. Right. From basic rules regarding vectors we know, vectors acting towards the same direction of consideration are considered as plus. Vectors acting opposite to direction of consideration are considered as minus. Right? If we have inclined vectors, they should be dissolved. Right? They should be dissolved like this. If you have inclined vectors, they should be dissolved into components. And if you have perpendicular vectors should be neglected. Right? Those are the basic vector rules. Right? You have written all 4 basic vector rules under linear motion, right? If you can't recall, we can recall and we can write it again if needed, right? You wrote all 4, right? Students, tell me, didn't we write all 4 vector rules under linear motion? Yes, we wrote. All 4 we wrote, no? All 4? Yes, very good. So that is the point that I am referring to, right? That is the point I am referring to. If they are same direction to the consideration, consider them as positive. If they are opposite to the consideration, consider them as negative. If they are inclined, dissolve them into components. This thing comes into play. And if they are perpendicular components, neglect them. Right? See? Now, my considered direction is, look at the board. See, my considered direction is vertically upwards. Then vertically upwards, initial velocity we have at this point is 100 sine 30. 100 cos 30 is perpendicular for my considered direction. So from 100 cos 30, there is no impact for the vertical direction because that is horizontal, perpendicular. They are neglected. And this 100 sine 30 is acting along the same direction of consideration. So it comes as a positive vector. So therefore, u is not 100 now, but 100 sine 30. Whole thing squared. Right? Plus 2, I'm using the equation upwards, but g is acting downwards. So this is minus g, and vertical distance from A to C, we are using the equation upwards. Vertical distance from A to C is exactly h. Vertical distance from A to C, yeah? Vertical distance, because this is the level of A. Vertical distance from A to C, h. Tell me if you have any doubts about the substitution. Plugging values, substitution of values. Tell me if you have any doubts about substitution of these values. Oh, is it clear enough? Clear. Sir, why You ignored and so why is you ignored and not V? V is vertical anyway. V is vertical and its value is 0. So I have substituted 0. And U is not ignored. Only 100 cos 30 is ignored because that is perpendicular. Right? Now simplify this. Simplify this. Simplify this. Take this entire thing to the other side. Then it becomes plus 2gh. 2g is 10h. And sine 30. Sine 30 is half. Sine 30 is half. Which means 100 sine 30 is 50 no? 100 sine 30 is 50. Sine 30 is half ne? Plug this value. Plug this value. Sine 30 is half. Right? Then this is 50. Which means this is 50 times 50. 1 0 do 0 cancels. And by 2 this cancels 25. So h is 125 meters. Which means this projection is going to reach 125 meters from the ground. Projection is going to reach 125 meters from ground. Right? Sorry, I mean why 100 cos 30 is ignored and not sin 30? Because only perpendicular vectors are ignored. Only perpendicular vectors to consider direction are ignored. Fourth vector rule. Fourth vector rule. We check the horizontal values of the cos 100 cos goes perpendicular. So we not consider fourth rule of vectors. Ah, yeah, you answered. Yeah, good. Thanks. Yeah, thanks. Right. So I thought you were asking a question from me. All right, thanks. 125 meters, which means this projection reaches 125 meters from ground. Any other questions? Any other questions? No, ask everything and clarify because this is a very first question you are going to see, and this is the initial ideas you are going to store in your head. All good? All good? Okay, if that is clear enough, take it down. Take it down. Okay, right. Okay, mention these points below with a red pen. Mention these points below the calculation with a red pen. Right, first point. Maximum height reached by the projection. 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 Maximum height reached by the projection occurs between A and B. Sorry, occurs between A and C. Occurs between A and C. Occurs between A and C. Next point. Next point. Next point. All basic vector rules should be followed. All basic vector rules. All basic vector rules. All basic vector rules should be followed. All basic vector rules should be followed. All basic vector rules should be followed. When using linear motion equations. When using linear motion equations. Should be followed when using linear motion equations. Next point. Next point. Perpendicular vectors to consider direction. Perpendicular vectors to consider direction. Perpendicular vectors to consider direction. Perpendicular vectors to consider direction are neglected. Perpendicular vectors to consider direction are neglected. Last point. Last point. Vertical velocity at maximum point. Vertical velocity. Vertical velocity at maximum point. Vertical velocity at maximum point of a projectile motion. At maximum point of a projectile motion is 0. Is 0. Right. So we are moving on to part 2. Part 2. Write down number 2. Right now we are discussing this as a question, no? As an example, no? Right? We are discussing this as an example question. So as part 2, write down what's the time taken. Write down what's the time taken. What's the time taken by particle to. What's the time taken by particle to. What's the time taken by particle to reach its maximum point? What's the time taken by particle to reach its maximum point? What's the time taken by particle to reach its maximum point? What's the time taken by particle to reach its maximum point? Right. Maximum point is 0. Then we are going to calculate the time taken to reach the maximum point. Right. Considering time, we know time is same in both motions. No? If you consider horizontal linear motion from A to this point also, the time is going to be same. If you consider the vertical motion from here to the maximum point also, the time is going to be same. But about the vertical displacement, we don't have any idea yet about the vertical displacement. But by now, we know few more facts about the vertical velocity and the vertical displacement. So therefore, you can think of the vertical motion again and apply a suitable equation to determine the time from A to Z. Before I show you the calculation, I'll give you 2 minutes to give it a try. Give it a try and try to get the value. Give it a try and try to get the value, the time from A to Z. We need time from A to Z. And if you got any answers, put them all to the chat boxes. Right? The YouTube ones also. One says 25 seconds. Salia. Salia says 25 seconds. What about others? Abhilaya, 5 seconds. Tarsana, 5 seconds. .5 seconds. Okay, let's see. Now, I'm going to do something like this. Again, from A to C, we need to apply an equation. From A to C, no? From A to C. And since vertical displacements are vertical details, vertical data are unknown, we are going to use an equation upwards. Right? We need the time, no? We need time. You need time. Now, simply what you can do is, we can apply V equals U plus 80, no? So, from here to here, I'm going to apply V equals U plus 80. V at my final point at C is going to be 0. It is 0. And U, vertical component of velocity is 100 sine 30. 100 sine 30. We are using the equation upwards. G is downwards. That is minus G T. Right? I'll mention this time as TAC. Take this whole thing to the left hand side. GTAC. So I'm substituting G meanwhile. G is 10. Then 10 TAC equals 100 sine 30. Sine 30 is half. Right? Then 1 0 2. This 0 cancels. TAC equals 10 over 2. 10 over 2, 5 seconds. The ones who got 5 seconds, that is correct. 5 seconds. 5 seconds. Right? So take it down, please take it down. And if you got any more questions, anything to clarify regarding your application, because I can see some different answers as well. If you need any clarification, feel free to ask. Any questions, or is it all clear? Clear. Clear. Good. Superb. Superb. Okay, superb. Right. Then part 3. Part 3. Part 3. Write down. Determine. Write down. Determine the total time. Total flying time. Determine the total flying time. Determine the total flying time. Total flying time of particle determine total flying time of particle. Determine total flying time of particle. Right? The time from here to here is called the flying time because it is flying from ground to somewhere else. No, that's called flying time in projectile motion. Flying time. Okay, right. Now, time from A to C is known by now, right? Time from A to C is known by now. So think of something to find the time from C to B, right? Think of something to find the time from C to B, from C to B, and if you add those two, add them together, you will get the total flying time. Or else there are some other options available as well. So if you are thinking about a whole new method, you can do something from that as well. Okay, try it. Again, I'll give you 2 minutes before I start. Try it. Now, once you understood these basic concepts about projectile motions, today the coming questions are going to be very easier. Coming questions are going to be like nothing. I'm serious. Because all the concepts of projectile motion is here. All the concepts are here. .5 seconds, one says. So can't we take time for A to C is equal to time from C to B? Not now, because without proving it, we can't use it. Without proving it, we can't use, right? So if it is proved as it is equal, then only we can use, right? So that is what we are going to see here, whether it's equal or not. If that is equal, we can use it as a proof here onwards. Now, since we don't know anything, we are going to prove it, whether it's equal or different. Got it? So therefore, try to determine time from C to B. Try to determine time from C to B using the known data by now. Using this known data by now. .51 says others. Any other answers? 10 seconds. Darshana, 10 seconds. So what's the time you have got from C to B? The ones who did the calculation. What's the time you have got from C to B? Anyone on YouTube? Any answers? What about the YouTube ones? .5 seconds. 17.5 seconds. Now what's the reason you are getting different answers? Right? Now I taught you all as a whole batch. What it you are getting different answers. Right? See the variation from 0.5 to now up to 17.5. I have a range of answers. I can see a range of answers. What's the reason? What's the reason? Right? 0.5, 2.5, 17.5, 10. Right? Why is that? Why is that? Okay, let's see. What's the possible equation we can use from C to B? What's the possible equation that we can use from C to B? From C to B. Now I'm going to use an equation from C to B. From C to B. Do we know the velocity at B? Do we know the velocity at B? Tell me that thing first. Do we know the velocity at B? No, we don't know. We don't know. That is not zero. That is not zero because the projectile is striking with ground again. It strikes with ground. It is going to collide with ground. Otherwise, it is not going to come to the ground like with a gradually decreasing speed. No, it is going to strike ground. So therefore, there's a velocity here, a non-zero value. Velocity is zero, that we can't consider, right? But we know h. So therefore, we can't use v equals u plus ad. I'm going to use an equation like s equals ud plus half ad squared. I'm going to use an equation like s equals ud plus half ad squared downwards. S equals ud plus half ad squared downwards. Right? S is from C to B. That is also h, because when it is reaching down, right, it should cover same h. And u, my initial point is C. U initially, but we know there's no velocity in the vertical direction. So therefore, this is going to be zero. This is going to be zero. 0 times C is 0, no? Plus half. We are using the equation downwards, plus g 10 t squared. Right? H is known 125. Plug these values. 125 equals half into 10 means 5. 5 t squared. This is divisible by 5. Divisible by 5. 5 times 25 is here. Right? Which means t squared equals 25. So t equals 5. T equals 5 seconds. T equals 5 seconds. The time from B to C is also, C to B is also 5 seconds. What we needed was the total flying time. Therefore, total flying time. Therefore, this is the final answer. Therefore, total, let's say this is TCB, TCB, right? Then total flying time, that is T from A to B, TAB equals T from A to C plus T from C to B, which means TAB equals 5 plus 5, 10 seconds. Total flying time is 10 seconds. I saw the correct answer in the chat from few students, but so few different answers as well. Make your corrections, and if you have any questions, any doubts regarding your application of equation or anything other than the application, about any other thing about the vector usage here or something like that, please feel free to ask. Take it down. Take it down. Any questions? Any questions? Is it all clear up to this point, students? Is it all clear up to this point? Yes. Superb. Superb. Right. Okay. Now for this, we have a method 2 as well, and this is actually shorter. Now from here we have one learning. See, that is the answer for that question you raised before. See, now TAC is also 5, TCB is also 5, right? Times are equal if the projectile motion is symmetric only. Times are equal if the projectile motion is symmetric only, which means if a projectile motion starts from somewhere here and say it stops from somewhere here, because there can be projectile motions occurs at two different levels, something like this. I do the projection somewhere here and going to catch up here. Do the projection somewhere here and going to catch up here. Two different levels. In such cases, times are different. But if there is the same level, that is called a symmetric projectile motion. If there is symmetric, time taken for the first half equals time taken for the second half. Right? So first, mention this point in red. Mention this point in red. Times taken for times taken for times taken for first half, times taken for first half and second half, times taken for first half and second half of a projectile motion, of a symmetric projectile motion, of a symmetric projectile motion, of a symmetric projectile motion are equal, of a symmetric projectile motion are equal. Right? Underline or highlight symmetric. Underline or highlight symmetric. Underline or highlight symmetric. Symmetric. Right? Okay. Shakina, you are joining late. Eh? What's the reason? What happened? Did you join just now? Or were you there before? What happened? After school? Or you forgot the time of the class? Join the class on time. Join the class on time. This week I have chess till late. Okay. Now, for you guys, is there any festival or something in these days? I'm just asking because of the curiosity to get to know. Is that a festival season? Festival or what is it? Now, the combination of the class is nice. Like we have single students and we have Muslims, we have Tamils, we have the Catholics, right? So that's the combination. That's a nice combination. No, our church an annual Bible study. All right. Okay. That's fine. Right. Good. Yeah. Try to manage both. Like now, annual means that is just only for this week. No. Yeah. That is better that you are joining those extra curricular things as well. So manage both. Right. And what I was going to tell is we can do this using a method 2 as well. See, as a method 2, this is actually easier. As a method 2, I'm going to apply an equation from all the way from A to B. See, from A to B, we did the same. We did the same in linear motion as well. If you need to find the total time, we did the same thing in linear motion. We can apply an equation from starting point to end point at once, right? Think and tell me what is the vertical displacement from A to B. What should I substitute for S here? HO, 2HO, what is it? What is it? What should I substitute as H as S here? If I'm using the equation from A to B vertically upwards, then S should be the vertical displacement between A and B, right? S should be the vertical displacement between A and B, that is 0. Very good. Excellent. 0. I got answers. Excellent. That is 0. Because there's no vertical displacement between A and B. They are at the same level. 0. U in the vertical direction is 100 sine 30. 100 sine 30 t. Here we are using the equation upwards. So g is going to be minus. So therefore this is minus half g t squared. Take this whole term to the left hand side. Half g t squared equals 100. We know sine 30 is half t. 1t to 1t cancels. 1t to 1t cancels. And plug g and simplify. And you can see half to half cancels. So t equals 100 over g is 10. So t equals 10 seconds. Can you see? So this is actually t from A to B. This is actually t from A to B. See, at once we can get this total if you use this equation from starting point to the end point. So therefore, this is the easiest and the shortest method to determine total flying time of a projection, right? So put some asterisk mark and take this down like this, because this is the must know method, because this is the shortest method that you can get the total flying time of the particle. Take it down. Write it down. Finished? Finished? Any questions? Any questions? Is it all clear? Clear. Right. Then use a red pen and put an asterisk mark and mention this point. Mention this point with an asterisk mark. Vertical displacement. Vertical displacement. Vertical displacement. Vertical displacement from A to C. Vertical displacement from A to C. Vertical displacement from A to B, A to B, A to B. Sorry. Vertical displacement from A to B. A to B. Right? Sorry. Vertical displacement from A to B is zero. Is zero since vertical displacement from A to B is zero since both points are at the same horizontal level. Since both points are at the same horizontal level. Since both points are at the same horizontal level. Since both points are at the same horizontal level. Okay. Number 4, part 4. Part 4. Part 4. Write down. What is the horizontal range? 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 What is the horizontal range of above particle? Above projection, let's say. What is the particle? Okay, fine. What is the horizontal range of above particle? What is the horizontal range of above particle? In a projectile motion, horizontal range refers to horizontal distance from A to B. Right? In a particle, in a projection, in a projectile motion, horizontal range refers to the horizontal distance from A to B. So therefore, it is denoted as R. Usually, this is denoted as R from here to here. This distance from here to here is called R. Horizontal range. R. Horizontal range. Right. So again, think of an equation and apply. Give it a try. Think of an equation and apply. Give it a try. Before I do the discussion, first think of which linear motion you are going to use and the points and the direction and use it. Right? right? One says 500 meters. One says 500 meters. Others. One says 500. Others. Any other answers? Any different answers? Are there different answers? Is it only 500? One. Others? No one else tried? Okay. First tell me, students, whether the horizontal distance is linked to, right? Whether horizontal distance is linked to horizontal linear motion or vertical linear motion. Tashi, 500 root 3. Tell me that to which linear motion it is linked to, it is attached to which linear motion? Horizontal. Good. Good. Horizontal. Then we have to do something by considering the horizontal motion, right? Since I need the distance from A to B, then I have to apply an equation from A to B. Right? It's clear now? So I'll be using an equation from A to B. Using an equation from A to B. Horizontally, what is the equation? I'm going to use S equals UD plus half AD squared. S equals UD plus half AD squared. Right. SC is going to be R. Distance from here to here. U. We are considering horizontal direction. Right. Horizontal component of velocity is 100 cos 30. So it should be considered. Times T. T from A to B is already known. T from A to B is 10. T from A to B is 10, already known. Plus half A. Tell me, what about the acceleration? Tell me, students, What should I substitute for acceleration? Plus g or minus g? Plus g or minus g? Quickly. Should we substitute plus g or minus g as acceleration now? My considered direction is horizontally rightwards and direction of g is vertically downwards. Tell me, students, please respond. Please respond, quickly respond. Oh, what's your thought? Plus g, minus g, or is it something different? I took it as 0. One says others. So what do you say? 0, plus g, or minus g, or something else? No horizontal acceleration? Yes, you got the point. There's no horizontal acceleration. 0, because acceleration is perpendicular to my considered direction. Vertical direction is perpendicular to horizontal direction. So it is 0. Neglected, neglected, neglected. 0. T squared doesn't matter. This whole part is going to be 0. This whole part is going to be 0. Then R equals 100 cos 30 is root 3 over 2 into 10. This can be cancelled. 2 times 5. So R equals 500 root 3 meters. R equals 500 root 3 meters. It is correct. Right, I saw the answer in the chat box. Correct. It is 500 root 3 meters. And most important thing is this: when we are using the equation horizontally, vertical vertical gravitational acceleration is neglected because that is perpendicular to the considered direction. Take it down. And if you have any questions, forward them. Any questions? Is it clear for all of you? Students, is it clear for all of you? Sir, will you explain the acceleration of the horizontal range? 0. Because acceleration is vertically only. Acceleration is vertically only. No acceleration in the horizontal direction. This vertical acceleration is neglected. Vertical acceleration is neglected because the direction of consideration is horizontal, but the acceleration is vertical. Fourth rule of vectors. Again, fourth rule of vectors. Perpendicular. They will be neglected. So therefore, no horizontal acceleration. Simple as that. No horizontal acceleration. Got it? Right. Excellent. Any other questions? Any other questions? Or is it clear enough? Good. Right. Okay, so below this, mention this point in red. Mention this point in red. G is neglected. G, symbol G. G is neglected. G is neglected. G is neglected. Since it is perpendicular to, since it is perpendicular to, since it is perpendicular to, G is neglected since it is perpendicular to since it is perpendicular to direction of consideration. Since it is perpendicular to direction of consideration. Right? 5. Part 5. Part 5. Part 5. Write down. Part 5. Write down. Determine horizontal velocities at points. Determine horizontal velocities at points B and C. 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 Horizontal velocities at points B and C. Right? Again, try it. I need the horizontal velocity at B and horizontal velocity at C. Right? For our is, let's label it as this. Horizontal velocity at B as, let's label it as VB. And let's label horizontal velocity at C as VC. Find VB and VC. Find it. And send me your answers. Any answers, friends? Hold on for 2 minutes. I'll grab the water bottle and come. Right? Yeah, we see a few answers. Tarsana, velocity of both B and C, 50 root 3, she says, at both points 50 root 3 meters per second. Right. Good, good. Good. Yeah, it is correct. See? Now, first, if I need to find velocity at B, since we are interested about the horizontal velocity, which means we need to think of horizontal motion. Horizontal velocity means horizontal motion because horizontal velocity is attached to horizontal linear motion. Then I'm going to use an equation from A to B. See, from A to B. From A to B, rightwards, we can use V equals U plus AD. We can use V equals U plus AD, isn't it? Right? Then V at B will be VB, and U here, we are using the equation horizontally. Then horizontal component should come 100 cos 30. 100 cos 30 plus here there's no acceleration times t. When VB equals 100 cos 30, which means 100 times root 3 over 2, VB equals 50 root 3 ms minus 1. And to determine velocity at C, again we can do the same, right? From A to C, rightwards, V equals U plus AT. V at C is Vc, and U is same as 100 cos 30, right? No acceleration, so this is 0. Again, this is also 50 root 3 ms minus 1. 50 root 3 ms minus 1. Right, good. Good. This is actually learning. Learning is this. In any projectile motion, horizontal velocity component is never going to change. In any type of projectile motion, horizontal velocity component is never going to change because there's no acceleration acts in the horizontal direction. There's no acceleration acts in the horizontal direction. So therefore, at each and every point on the trajectory, horizontal velocity remains constant as 50 root 3. Right? Got it? That is given for any projectile motion. Right? Take it down. Take it down if you didn't do. Take it down if you didn't do. Any questions up to this point? Anything to clarify? Any questions up to this point? Tell me, students. Any questions up to this point? Is it all clear? Good, good. Right. Mention this point in red again. Mention this point in red again. Write down below. Horizontal velocity component. Horizontal velocity component of a projectile motion. Horizontal velocity component of a projectile motion. Horizontal velocity component of a projectile motion remains constant remains constant. Remains constant. Since there's no acceleration. Since there's no acceleration. Since there's no acceleration towards horizontal direction. Since there's no acceleration towards horizontal direction. Since there's no acceleration towards horizontal direction. Right? Okay. Then part 6. Part 6. Part 6. Write down. Determine direction and magnitude. Determine direction and magnitude. Part 6. Determine direction and magnitude of velocity. Determine direction and magnitude of velocity of particle at B. Determine direction and magnitude of velocity of particle at B. Right. Listen. If it asks about, listen. If it asks about velocity, that doesn't mean vertical velocity. Oh, that doesn't mean horizontal velocity. Right? Neither vertical nor horizontal, which means that is about the actual velocity. That is about the actual velocity. Right? So, which means now we are dealing with horizontal and vertical motions. That is true. Now, after determining the horizontal and vertical velocities at that particular point, you can get the actual velocity using that resultant theory I explained before under that note. I explained before under the note. We are going to get the resultant. So therefore, now already VB is known. No? Already VB is known. Then what I need here to proceed is, right, already VB is known. What I need here to proceed is the vertical velocity at B that we don't know yet, right? I'll mark this vertical velocity at B as Y. I'll mark this vertical velocity at B as Y. So my first target is determining Y, right? Okay, students, do something and determine Y. First thing, do something, apply an equation and determine Y. And tell me what Y is. First, tell me what Y is. Determine Y. First task, determine Y. Determine Y. What about it? 50, 150? Why different answers again? Why different answers again? 50, 150. What else? What else? you have multiple options, more than one options, right? So think of an equation and apply. You have multiple options, right? You can do any valid application, you can do any proper application. What about others? What about others? Don't just stay as ghosts, right? Please do respond. Otherwise, I don't know whether you are sleeping or not. Right. To determine why, what I am going to do is I'm going to use an equation from C to B. From C to B. You can do any valid thing, right? From C to B downwards, simply I'm going to use V equals U plus AD. Simply V equals U plus AD, right? V is going to be Y. U is 0 because at 0 vertical velocity is at C vertical velocity is 0, right? Plus A is plus 10 and time from here to here was 5 seconds. So Y is 50. Y is 50 ms minus 1. Y is 50. Now all of you should get 60, get 50 by now, right? Now we are towards the latter part of this discussion here, and in the sixth part, right now you are comfortable with this thing. Now you are comfortable with the projectile motion, right? $50. Okay, now look at the board. This is what I'm going to do. Now I'm going to draw this again here for your clarity. At B, now we have two different velocities. One is horizontal. Horizontal velocity was VB 50 root 3. Horizontal velocity was 50 root 3. And now we have find the vertical velocity as 50. Right? Now, velocity means the real velocity. Real in the sense actual velocity. Velocity means actual velocity. The real value, real velocity. It is actually in between. It is actually in between the resultant value. The resultant value. Right? That is in between. So let's say that is V dash. Let's say that is V dash, which means the actual velocity is in between V dash. Right? That is why you learn the theory about resultants. About resultants, how to write resultant when you have two perpendicular vectors. Now we have got two perpendicular vectors. Then apply this on the equation and find the resultant V dash. Right? So if I quickly recall, if you have two vectors as x and y, this resultant vector can be written as, this we learned before, as root x squared plus y squared. Right? So we are going to apply the same here. Which means v dash squared, sorry, v dash, not squared, v dash can be written as, which means v dash can be written as root this thing squared 50 root 3 squared plus this thing squared 50 squared. Simplify this and tell me. Sir, can you explain getting y from A to B? Possible. What's the equation you applied? If you are using A to B? Is it V equals U plus AD again? Okay. See? Others, simplify this thing. If you also have done in this way, you can look at this simplification as well. If you are using from A to B, right? What's the direction you used? Vertically upwards or downwards? Upwards. Right? Then final velocity here. So we know this final velocity is y vertically downwards. I'm using the equation vertically upwards. So it is going to be minus y. Minus y. Right? Minus y. And u is sorry. Vertical velocity you asked, right? Okay, that's fine. Then u is 100 sine 30. 100 sine 30. And g is acting downwards, so minus 10 t. T from here to here was 100. T from here to here was 10. T from here to here was all the way from A to B 10. Simplify this thing. Minus y equals 100 sine 30 is 50 minus 100. So minus y equals minus 50. Y equals 50. Same thing comes. Y equals 50. Right? Okay, what about this? What about V dash? Others? What was the value? What is the value for V dash? Anyone who simplified? Anyone who simplified, what's the value? Come on, students. What's the value? No one simplified? Root 50 root 3, no? Right? So we can do this way. This is 50 squared times root 3 squared. Root 3 squared is 3. Root 3 squared is 3. One says 100 root 3. Then this is again 50 squared. Now can you see 50 squared is common? Take it out. Can you see 50 squared is common? Take it out inside. No need to simplify the number. Take this out, 50 squared. Then from this bracket 3 remains. From this 1 remains. Right? Now this is about the square root of 50 squared. The square root of 50 squared is 50. Because this is like this, no? Square root of x squared is x. Like this. Square root of x squared is x. So likewise, square root of 50 squared is 50. So I'm taking it out. 50. Then inside root, 3 plus 4, 3 plus 1 means 4. 3 plus 1 means 4. Root 4 means 2. Root 4 means 2. So V dash equals 50 times 2, right? So it simplifies. V dash equals 100 again. V dash equals 100 again. V dash equals 100 again. 100. 100 again. Right? So if you didn't do the calculation. Now this is also learning. This is also learning we are going to learn today. You are going to learn today. 100 was, see, 100 was the initial velocity given, which means the projection is again strike back the ground with the same speed, with the same velocity. Right? That is also possible. That is also satisfied by a symmetric projectile motion only. That is also satisfied by a symmetric projectile motion only. Take it down. Take it down. Any other questions? Okay. 100. 100. So that is also learning. That is also learning. Then I ask about the angle. Right? Direction at the angle means direction. I ask the direction. Direction means we have to find the angle. So let's label this as alpha. Label this as alpha. Right? From that same thing, you know how to write tan alpha. Write tan alpha. Tan alpha equals opposite side. This 50 is equal to here if it is extended. So opposite side is 50 over adjacent side 50 root 3. 50 to 50 cancels, which means tan alpha equals 1 over root 3, which means alpha equals tan inverse 1 over root 3, which means, right, now inverse value. Inverse means to which angle of tan 1 over root 3 occurs. That is the inverse, right? Which means it is like this. We know sine 30 is half. Then sine inverse half is 30. The exact opposite of that. To which value of the angle that value comes, right? As sine 30 is half, sine inverse half is 30. Now, tan inverse 1 over root 3 is, I gave you all these values in the table. Tan inverse 1 over root 3 is 30. Because tan 30 is 1 over root 3. So tan inverse 1 over root 3 is 30. Alpha is 30. Alpha is 30. That is also learning. That is also learning because my projected angle was 30. And now when it hits the ground also, it makes an angle 30 with the ground. If you extend this, you can see this clearly. If you extend these two, this is also alpha. So therefore, it is going to hit the ground with the opposite angle. Opposite angle in the sense, now this angle was made from right to left and this angle is made from left to right. Right? It's an opposite angle, but the same value, same angle when it hits the ground. Right? මෙහෙම ඇවිල්ලා මේ පැත්තෙන් strike කරනවා. Got it? Lay it down. Right? Any questions up to here? Any questions up to here? Anything to clarify? This is the magnitude 100 and this is the direction 30 degrees incline. 30 degrees incline. Right? So it says this angle is 30 now. So which means he is hitting the ground with the opposite angle like this. With the opposite angle like this. Same 30. Opposite direction. Same 30 to the opposite direction. Okay, students, tell me. Any questions up to here? Any questions up to here? Anything to clarify? Tell me. Please respond. Students, please respond. Any questions? If that is all clear, at least put a thumbs up or say it's clear. All clear. Right. Good. Okay. With a red pen, again mention this point below the calculation. Mention the point. First point. First point. First point. The particle strikes back. The particle strikes back. The particle strikes back to ground. The particle strikes back to ground with the same initial velocity. 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 If it's a symmetric projectile motion. 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 Okay, next point. Next point. Angle made with horizontal. Angle made with horizontal. Angle made with horizontal. Angle made with horizontal is also same. Is also same. When it returns to ground, is also same. When it returns to ground, is also same. When it returns to ground for a symmetric projectile motion. 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 Right. Okay, listen now. Listen now. Now, this is all about the foundation of projectile motion. These are the basics. These are the basics. Right? This is the foundation. Now today, listen. Today we have laid the foundation. You have built the foundation for the house of for the building of projectile motion. You are going to build up. Now the foundation is done. This is the foundation. Right? That's why I told you, if you understand the concept of the horizontal and vertical linear motions about the projectile motion is nothing. Right? Projectile motion is going to be nothing. So therefore, this is all the theory parts, right? Basic theory parts, right? That we have in projectile motion. There are two more proofs coming up in the coming part. Two more proofs. Now here we have had like 5-6 proofs here. May occur proofs like the velocities are same, angles are same, times are equal in 2 halves. All of them are proofs. All of them are proofs, right? And few more proofs are coming up. And horizontal velocity component of a projectile motion remains unchanged. That is a proof, right? And 2 more proofs are coming up. And this is almost the end of the theory parts and the foundation of projectile motion. The foundation. Now, since the foundation is laid, right? Since the foundation is laid, next day we'll be spending the entire day with the questions of projectile motion, right? We will be spending the entire next day with questions of projectile motion, and most probably we'll be able to finish projectile motion by next day, right? Most probably we can finish off by discussing all the questions, right? Any questions? So would the angle ever be negative if it is in clockwise direction? if an angle is measured in clockwise direction, that is not going to be negative. To get a negative value, there is something coming from. You are doing maths, right? Are you doing maths? Yes. So in maths, you have something called quadratics. Quadratics. 1, 2, 3, 4 quadratics. So based on the quadratic, the angle or the sine, cosine values of angle changes. Right? Otherwise, standard direction of measuring angles is the anti-clockwise direction. That is the standard direction of measuring angles. Anti-clockwise. Correct? Otherwise, the negativity comes with the quadratics. That you will learn if you haven't learned yet. In maths, you have something called quadratics. Right. So, yeah, now since all theories are done, all the basic parts, foundation parts are done, next day we will be starting all the applications. And by now you have got the route now, right? Because I posted the old routes before the first week this month, right? Before the first week. Now, by now, all of you have got all the routes. So be ready. Be ready. Next day, we'll be discussing all the questions, all the question types here in projectile motion and going to wind this up. Right. Okay. So it was a good session today because I covered each and every aspects of projectile motion about the basics. And it seems all of you and the most of you have understood the lesson and most of you engage giving answers. So that's an indication that you have got it. Right? Very good. Okay. Any other questions? So if you understood the lesson better, now since this was a free seminar, I have live streamed this on YouTube as well. Right? If you have understood this better, if possible, you can go to the YouTube video. Once the YouTube video, in the sense YouTube live video, once the live video is ended, you can add a comment as everyone can see whether you are clear about the lesson or not. Right? So if you are crystal clear about the lesson, the ones on YouTube and the ones on here also, in a free time, you can go to that YouTube video and add a comment. Then in a leisure time, I also can check whether you have understood the lesson properly. Right? Okay. Any other questions? One last time. Any other questions? So when is the spot exam? As the name suggests, there is a spot exam. That will be spot on, right? There is an impromptu one, right? It will be on one of the days during the month. Spot means you have to face it on the spot. You have to face it impromptu, right? Impromptu. So prepare yourself for the exam. It might be on next day, next week, or week after next week, or I don't know, somewhere inside the month, during the month, right? Mara questions there is a spot exam. There is a spot. And from which lesson you are going to get the next spot exam? The last one was units and dimensions, right? And measurements. Last one was measurements. So next one you are going to get is from linear motion. That I can say. Next one you are going to get is from linear motion. So go through all the parts in linear motion and be ready, right? And if you haven't written the last spot exam yet, if you haven't submitted the answers for the LMS for the website yet, submission will be closing by tomorrow. I'll be closing the submission by tomorrow because now it's 7 days after the date of conduction of the exam. So therefore, I'll be closing it tomorrow and going to evaluate and give you the final marks after tomorrow. Right? Okay. Any other questions? No. Right. Okay then. Since there are no more questions, right? We'll wind up the class here. Please go through these parts again and again and practice these things we did today, because you are going to spend the entire next day with projectile motion questions, starting from simple questions and moving towards the advanced questions, right? So go through all the things and practice and make comfortable yourself with the lesson, right? Then easily you can do the questions coming up on the next day, right? All right, then we'll be winding up, and we are going to see again on the next day, on next week, right? All right then. So until then, goodbye and good night. Stay safe and work hard. Good night and goodbye.